Part 2 of the divisions property of exponents has more powers raised to powers, and you also have to be careful. The directions on the second half here ask us to simplify if possible, so some might already be simplified. So let's take a look at the first one. Now all of these can be simplified further, but some of the problems that you might encounter, maybe one, may already be simplified. Well, first thing I would do on these problems is if I have a power raised to a power, look to see if you can reduce anything inside the parentheses to start with, and we can. See here, there's an x on the bottom, and that is an x to the first power. Well, we can take away one of the x's on the bottom and one from the top, leaving us only with one x left on top. So rewriting our problem, it would look like this: x to the first power over y to the third, all to the third power. And see, this is a whole lot easier to simplify than what we had before. Less numbers to deal with. So from there, what I'm going to do is use the property I used before. When I have a power outside the parentheses, just means I have three groups of what's inside. So the rule is I can multiply those exponents. So when I do that, I'm left with an x to the third power. 1 times 3 is 3. And down below I have y to the ninth, because 3 times 3 makes 9. And there's our answer. It's as far as we can go. Well, taking a look at this next one, we have some more work we can do in the problem. You see, down in this area here, we can simplify this. See, I can't take away these a to the thirds here because this a to the third is in parentheses. So let's clear this parenthesis first. So I'm going to just multiply the exponent on the outside by the exponents inside. So I still have a large majority of this left. I still have these large parentheses. I still have an a to the third on top. But down below, I have an a to the sixth and a b to the second. And then I still have this large parenthesis with the 2 on the outside. So this is all still here. So all I did is simplified this portion right here. 3 times 2 made 6. 1 times 2 made 2. Now I'm going to go ahead and reduce. So you see how I'm not going to clear this parenthesis quite yet. I see that there are 3 a's on the top, in which I can take 3 a's from the bottom, leaving me with 3 a's on the bottom of the fraction. Now when I do that, I've canceled everything out on top, but we still need to show that there's a number up there, and that number is 1, because 1 times any number is still that number. So I still have a 1 up on top, but an a to the third and a b to the second on the bottom. And we still have this all raised to the second power. Well, now we can go ahead and multiply exponents. So you see, if I put a 1 here, 1 to the first power is still just 1, but I'll go ahead and multiply the exponents anyhow. And when I do that, now I'm left with a 1 to the second over an a to the sixth and a b to the fourth. Well, I really didn't need to multiply the exponents on the 1 because 1 to the second is still just 1. So we can write our final answer as just 1 over a to the sixth and a b to the fourth power. There would be our answer. Well, the next one seems a little more complicated. It has 2 different parts to it. First of all, we don't see exponents on the 2 or the 3, so you can put a 1 as those exponents and multiply the exponents. That's the rule. Same thing here, except before I do this, I see I have some common factors. I have an a to the negative first power. I have some a's down below too, but remember the rule is to take the reciprocal of negative exponents. So when I do that, here's what I'm left with. I got a 2 to the negative first over a 3 to the negative first. And on this fraction, I have a 3 still on top, but now I have a 2 on the bottom and a to the fifth on the bottom. The way I got that is when I move this a to the negative first down, it just becomes a to the first power. Well, a to the first and a to the fourth make a to the fifth. I'll close those parentheses, put the negative 2 on the outside, and now let's go ahead and multiply the exponents to clear the second set of parentheses. So we'll put a 1 on these exponents here, because they don't see the exponent, and multiply all those exponents. So let's see what's left over. Well, when I do that, I still have this 2 to the negative first power, 3 to the negative first, and then over here I have a 3 to the negative second. Down below I have a 2 to the negative second power, and I have an a to the negative 10th. Well, from that point, we can go ahead and start moving some terms around. So I don't want to take exponents until I make them positive. So you see, everything has a negative exponent, so we're just going to take the reciprocal of everything. So these are going to move down below, this is going to move up top. And you're going to do the same thing with this fraction. Everything on the bottom here is just going to move to the top of that fraction. And so let's see what's left over. Well, we've got on top, we've got now a 3 over 2. And then over here, well, these 3's went down below. And I'll go ahead and leave them there, and I've got a 3 squared on the bottom now, but I've got 2 squared on top, and an a to the 10th. Well, the only thing to do is just to reduce this fraction. So you see how I've got some 2's that I can cross cancel. And the way we're going to do that is we are going to just reduce the fraction, just like we typically do by looking at the exponents. So here, this 2 here will cancel out one of the 2's here. This 1, 3, see it's 3 to the first power, will cancel out one of the 3's here. So all I'm left with is a 2a to the 10th all over 3. And that is our answer. Well, next one here, similar to that, in that we have some extra parentheses inside the top of that fraction. So we're going to go ahead and clear that first. So I see there the 3 has an exponent of 1, so I'm going to multiply those exponents. So what am I left with? Well, still have this big parenthesis. Now it's 3 to the second, because 3 to the first to the second power is 3 to the second, and an x to the sixth. So it's 2 groups of 3, which makes 6. Down below, we've got a 9x to the negative first, and it's all still to the second. We've got positive exponents there, so let's go ahead and multiply out those 3's, and we've got now a 9x to the sixth over a 9x to the negative first, and this is still all to that second power. Well, let's go ahead and reduce this fraction and move some exponents. So these 9's will cancel out. 9 over 9 makes 1, but this x to the negative first goes on top. When we move it on top, it becomes a positive exponent. It becomes an x just to the positive first power. And now we can combine those. So let's see what's left. Well, now we just have an x to the 7th left on top. Nothing's left on the bottom except for 1. So we're going to bring everything to the second power. This 1 doesn't need to be brought to the second. Showed you on this problem here, 1 squared just makes 1. So we'll just go ahead and take 2 groups of x to the 7th, which would be x to the 14th. And that would be our answer. Well, the next problem has some coefficients we can reduce. So remember how I had divided this into separate problems before? We can do the same sort of thing on this one as well. So we go ahead and do that, and we look for that common factor. And so I see that 6 goes into both the 12 and the 18. And so let's go ahead and rewrite what's left over once I do that. Got a big fraction bar because I've got to leave room for some x's and y's. And now I've got 2 left on top, 3 on the bottom. Clear some x's now. And so here I've got 2 x's on the top, which will cancel out 2 x's on the bottom. So take away 2 there. And so what's left over? Well, just 1x on the bottom of the fraction. Let's look at the y's. Now the y's, well, those are negative exponents. So let's just take these negative exponents and let's switch their location. Take these and bring them up top. And so let's rewrite what we've got. So now we've got a y to the 4th power on top, y to the 3rd power on the bottom. And this is all still to that 2nd power. Well, we can go ahead and reduce that. We can take out those common y's. So 3 y's are going to cancel here. Take away 3 from here leaves us with 1 y left over. So what do we have now? We've got a 2y on top and a 3x on the bottom. Still all to the 2nd power. Well, now we go ahead and clear that parenthesis by multiplying the exponents, because it's a power raised to a power. If you don't see exponents, it's just 1. So we go ahead and do that, and we've got 2 squared, y squared. Down below we've got 3 squared and x squared. And then all you have to do is just multiply out those 3's and 2's. So what's left over? Well, we've got a 4y squared. Down below we've got 9x squared. And that would be our answer. Well, last problem here. So on this one, show that problem a little bit easier here. We've got some exponents that we can clear in this fraction. So I see how we've got some common x's, and we have an x to the 0. Remember, any number to the 0 power is what number? 1. Hopefully you remember that from way back on the first day we dealt with exponent rules. So any number to the 0 power is just 1. And then cancel out some x's here. So these 4 x's will cancel out. So I'm taking away 4 from the top, take away 4 from the bottom, and all we've got are 4 x's left in the bottom. But we still have that negative 2 on top, and it's now x to the 4th on the bottom of the fraction. But it's still all to the negative 3rd power. Well, from that point, if you don't see an exponent, you put 1. Now notice this negative 2 is in parentheses. So it's negative 2 to the negative 3rd power. So I just did 1 times negative 3 to get that exponent of negative 3. Same thing over here. X to the negative 12th power. 4 times negative 3 made the negative 12. So from that point, don't take the exponents. Common mistake is people want to take these exponents now. Don't do that. Take the reciprocal first. Make these positive exponents. Put those down below. Put these up top. Let's see what's left over. We've got now an x to the 12th on top. Down below, we've got a negative 2 all to the 3rd power. So now we can multiply out these negative 2's. And it's an odd number of negatives, so it's going to make a negative. And so what are we left with? X to the 12th on top. And we have a negative 8 on the bottom. Now it's negative because it's 3 negative 2's being multiplied together. So this makes a positive 4 times by negative 2 makes that negative 8. And that's how they get the answer. Good luck on tonight's homework.